Hey everyone, welcome back. So now we're going to learn some cool new stuff. So we are going to uh, implement the principal component analysis techniques on images. Okay, so PCA has a lot of applications, especially when your data has high dimensions, because remember it is a dimension reduction technique. So we are going to learn how to implement PCA on images. So basically we are going to so images are high dimensional data sets, and we will use PCA techniques to reduce the dimension of these images. Okay, so this is an important application of PCA. But before we can actually implement PCA on images, we have to learn how to process images, basically how to read, write, and do some basic manipulations or basic operations on images in R. So we're going to first learn how to work with images in R. Okay, so so in this lab we shall focus on the very basics, that is image reading and image writing. So in problem 1, first, so we read the canoe.jpeg image. So the images, the image format that we will use is JPEG, and you can find this image on Canvas. So there is a folder. So if you go to the files, you'll see that there is a folder called images, and that's where you'll see all of these images that we shall use. So go ahead and download that image. You need it before you can start working on this lab. So once you have the image called this canoe image, you'll install this library JPEG and library imager. Okay, so for the Mac people, I'm pretty sure you're going to run into library related issues for this one. So make sure if you do face this issue, just switch to R Studio, R Cloud. So there is this function called plot_image.r. So I have written this function to help you plot images in R. Okay, so for me this code is in this folder called source. So when you run this file, you will have to change this. Okay, so this code is, again, if you go to the files, you will in files go to the folder labs, and in there you will find this code. Okay, it is an R code. Make sure you change the path. Okay, this is my path and you should remember to change it. All right, so with that, read JPEG. This is the file, this is a command that will help you run read images in R. Again, remember this is my path, right? This is the name of the file, and everything below that is the path where this file is stored. So you need to change yours accordingly. So now with this command, I have read this image in PIC. Now how can I visualize it in R? Okay, so for now just run this code, don't worry about it too much. We'll try and get to this later, but now let's just try to visualize images in R. So if you run this, you can visualize it in R. Okay, so this is the image and this is the canoe. All right, so what kind of an object is this, right? So is it a data frame? Is it a matrix? Is it a vector? What is it? Or is it something else altogether? So as you remember, we can use the class function. So if I look at class of PIC, it is an array. So it is important that you understand the format of the data, right, before you start working with it. So that is what we're trying to do right now. So if I want to see the dimension of this array, it says this. So what does this mean? Okay, so if I visualize this image, okay, it's a box, right? So what this array means is, first of all, this last number here means that there are 3 objects in this array. So you should go ahead and read up some material on how arrays are stored in R. So this last number here means 3. That means there are 3 objects in this array, and these objects are matrices. So if you think about it, if you do dimension of a matrix, you'll get the number of rows and number of columns, and that is what you're seeing here. So there are 3 matrices, and the dimension of each matrix is, or each matrix has 450 rows and 600 columns. Okay. So why are there 3 matrices? So there are 3 matrices because this is a colored image. Okay. And when colored images are basically made up of values of red, green and blue color, the RGB scale. Okay. So for each pixel, okay, so each pixel is like a cell in the matrix. Okay. So so each pixel corresponds to the cell, and for each pixel it's a colored pixel, right? So there are 3 components. So there's a red intensity, green and blue intensity, and those are stored in these 3 arrays. Okay. So let's try out this. So what I'm doing here, so now picture is an array. I told you it's an array of length 3. And so if I do this pick comma comma 1, that means this is the first array, the second array and the third array. So this notation is not too different from how we access elements inside a matrix. However, now you can see that there are these 3 dimensions here. Okay, so what am I doing next? I am dividing each of these arrays by the maximum intensity. Okay. And if I do that, and if I plot my picture now, it appears as black and white. So what I have done is I have converted this colored image to a black and white image. And now, because so it's a bit cumbersome to type out this code every time. So from now onwards, if you want to plot an image, you can use this code that I've uploaded, or this. So the code contains this function called plot image. The first element is the object that you want to plot, and the second one is the number of columns in that object. Okay. So you can see that it gives you the same thing. Okay, output of this and this is the same. This looks much neater, so this is what we will be using. All right, so this is the canoe image, and we saw how to read it. We now have an idea of how images are stored in R. They're stored in arrays. So each pixel of an image is basically one cell in that matrix, right? So it's an array of matrices, and each cell, each pixel corresponds to an element in the matrix. All right, so there is another image called Cape Town. Make sure, so go ahead, download that. Again, you can find it in files in the folder called images. So we read this into this variable called photo. We plot it. This is an aerial image of Cape Town. Does it appear colored? Okay. No. Find the dimension of the image. So let's see. So it's still an array. Okay. So here is the question, right? So initially I told you it's an array because for colored images you have the red and the green and the blue component, but we don't need that for the black and white images. So even though it appears as colored, R currently thinks it's black and white. So you have these 3 components in this array. So what we are going to do is we are going to convert this so-called colored image, it's not, right, into a true black and white image. True black and white image using this code. So again, so I'm adding the 3 parts of the array and I'm dividing by the maximum. And then this command here is to save images from R. So write jpeg. So I've written this jpeg, and the name of that file is B&W, that's black and white photo. Okay, then I'm going to read this B&W image. So I do that here. Again, I'm rewriting it into this photo. Okay. So now if I look at the dimension, it is just a matrix, right? It has 424 rows and 1920 columns. You can see that it's a long image, right? Or it's a wider image, sorry. Therefore, it has more columns and rows. So now this black and white image, or the true black and if an image is truly black and white, all you need for storing it is a matrix, where each element in that matrix corresponds to a pixel, and it gives you the intensity of that pixel. Okay, so in this course we will mostly work with black and white images just to make life easy. I mean, anything we can do to a black and white image we can also do to a colored one, but it just complicates things a bit further because then you have to look at the red and the green and the blue components as well. So in this lab, basically it will teach you how to first of all read an image. Then you want to make sure, check the dimensions. Even if it appears colored, black and white, you want to make sure that it is a single matrix and not an array. If it is an array, now you know how to convert it to a matrix. So this is what you do, and then you save it, and then you use it for further purposes. So again, we'll view this photo, right? This black and white image that we just read, and I stored it in photo. If I read it using this plot image function, this is how it appears. So it appears the same as before, except now its dimension, it's a matrix. It's not an array, it is a matrix. So if it's a matrix, then does it make sense to, you know, look at its transpose, addition, division, subtraction? Can we do those kind of things to it? So let's see. So here I have taken a transpose. So remember, in plot image, I first give the image, then the number of columns. Now, so instead of photo, I want to look at the transpose of photo. So I have T of photo, and I have n number of columns in this T of photo. And as expected, it gives me transpose of the image. What if I multiply my matrix by 0, right? And if I plot this, it looks black. So basically, darker values mean smaller numbers correspond to darker values, right? And if you want a completely black image, then your matrix has to be full of zeros, right? So color black corresponds to the number 0. Okay, so now I'm just creating a matrix of values 5. It has 424 rows, 1920 columns. And if I plot this matrix now, so remember, I'm not plotting even an image anymore. I have just created this matrix. It's full of constants. If I plot it, I get this image. Okay, so remember, 0 was black, 0.5 is gray, and if you put a 1, you don't see anything because 1 corresponds to white. Okay, so 0 is black, 1 is white, and in between you get a range of colors or shades between between black and white. So that's all for this lab. So make sure you go ahead and try out these commands and you're comfortable reading, writing, and doing these basic manipulations to matrices and more specifically images. All right, see ya.